Today we're talking about zeros of polynomial functions. We're going to begin with the factor theorem. So for any polynomial function f, x minus k is a number here, so x minus k is a factor of f of x if and only if f of k equals 0. Now, this if and only if may not be familiar language to you, but I'm sure you're familiar with an if-then statement. So, if it is raining, then the sidewalks are wet, where we might have, you can't reverse that kind of statement because it may not be true that if the sidewalks are wet, then it is raining. But if and only if is a if-then statement that goes both ways. So if x minus k is a factor of f of x, then f of k equals 0. And it's also true that if f of k equals 0, then x minus k is a factor of f of x. So this k is called a root or a zero of the function f. These two vocabulary words will be used interchangeably. You will be expected to know that they are interchangeable, and you will be expected to be able to handle a problem whether it asks for roots or zeros, and you should know that those are the same things. So let's have some examples. So if I have this polynomial function, f of x equals x cubed minus 19x plus 30, I'll go ahead and tell you that that factors as x minus 3 times x minus 2 times x plus 5. And so now we can see clearly that x minus 3 is a factor of this polynomial, which means that according to our factor theorem here, f of 3 should be equal to 0. So let's look. 3 cubed will be 27 minus 19 times 3. Well, this is 57, so 27 minus 57 is negative 30, and plus 30, that will indeed be 0. It's also it's easier to see if we look at the factored form. Notice that if I substitute 3 in for x in the factored form of this function, I'll have 3 minus 3 times 3 minus 2 times 3 plus 5. So I'll have 0 times something else. It doesn't really matter what these other numbers are. 0 times anything will always give you 0. We can look at another example. I've got this polynomial, x to the 4th minus 9x cubed plus 2x squared plus 84x plus 72. That can be factored as x plus 2 times x minus 6 squared times x plus 1. So since x minus 6 is a factor of this polynomial, 6, when I substitute in, will give you 0. You can get a calculator and check that that calculation is correct. Also, notice that x plus 2 doesn't seem to be in the form of x minus k, but x plus 2 is the same as x minus a negative 2. And so if I substitute in a negative 2 into this function, I will get a 0. So negative 2 is a root or a 0. Remember, those are interchangeable. 6 is a root, and negative 1 is also a root of this function. So, interesting fact. A polynomial function of degree n has at most n distinct zeros. So here's our cubic polynomial from the previous example. We had that factored out. So we have 3 different zeros. So 3 was a 0, 2 is a 0, and negative 5 is a 0. If it feels strange to you to say 3 is a 0, you feel free to use our other vocabulary word. 3 is a root, 2 is a root, and -5 is a root of this function. So the degree of f is 3, and f has 3 distinct zeros. Now notice this does say at most, and I even bolded that. So let's look at another example. Here's a 5th degree polynomial, and that factors as x minus 1 cubed times x plus 3 squared. So the roots of this polynomial are going to be 1 and -3, and that's it. There are no other zeros to this function. There are no other values that would make this 0, because if there were, there would be additional factors. So the degree of g is 5, and g has 2 distinct zeros. Those zeros are 1 and -3. Notice how this happened was I've got x minus 1 cubed. Since this is cubed, that's how since this one's cubed and this one's squared, that's how I got to a 5th degree polynomial without having more than 2 zeros. And the number of times a 0 occurs is called the multiplicity of the 0. So here, the 0 of 1 occurs 3 times, because the factor of x minus 1 occurs 3 times in this factorization. If you wanted to, you could write this out as x minus 1 times x minus 1 times x minus 1 times x plus 3 times x plus 3. So the root of 1 has a multiplicity of 3. The root of -3 has a multiplicity of 2. And to test whether k, remember k is a number, is a root of a polynomial function, you can either test whether f of k is 0, that is, just plug it into the function and see if you get a 0, or you can test and see if x minus k divides f of x evenly. Now, at first, it might seem that this is a much more cumbersome way. Testing that division seems like a much more cumbersome way of testing rather than just plugging in and seeing if you get 0. However, there are some advantages. An advantage to testing whether x minus k divides f of x evenly is if it does, then you'll know what that quotient is, and you'll be able to factor that to find even more zeros of the function. We'll have another video in this module that will go through that process. And also, that division does not have to be that cumbersome, because remember, we have that new shortcut of synthetic division that allows us to divide as long as we are dividing by something that is linear. That is, it's just an x, it's not an x squared, x cubed, or anything like that, and the slope is 1. So notice that x minus k, where k is a number, is always going to meet those criteria. So you will always be able to use synthetic division in these circumstances when you're testing to see if x minus k divides a polynomial evenly. And I want to remind you that dividing evenly means that you get a remainder of 0.